Welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 4 from the October 2024 Mechanics M1 paper from Edexcel International A-Level. And this question here is about speed time graphs, and the points A and B lie on the same straight horizontal road. Figure 2 on page 11, which I've just brought down here anyway to make it easy for us, shows a speed time graph of a cyclist P for his journey from A to B. At time t equals 0, P starts from rest at A, and accelerates uniformly for 9 seconds until his speed is v meters per second. So 9 seconds, speed has become v meters per second, accelerates uniformly, so it's like a straight line. Okay. He then travels at constant speed, v meters per second, so he's at the same constant speed he travels. When t equals 42, cyclist P passes B. Okay, so the point B he passes at 42 seconds. Given that the distance AB is 120 meters, show that V equals 32. So basically, the distance that he's traveled in this time is 120 meters, and from a speed time graph, to find the distance, we need the area under the graph. So the area of this shape, which is a trapezium, the area of this shape, which is a trapezium, is going to be 120. Okay, now this trapezium is made up of a pair of parallel sides whose lengths are from 42 minus 9, that's going to be 33, right? 33 plus 9 is 42. That's right. And this length, of course, is 42. And the distance between the parallel sides, okay, which is what we need, is this distance here, which we don't know. And that is what we have to find, which is V. And we know that for a trapezium, the area of a trapezium is equal to, it's a half times A plus B times H, where H is the vertical height, A and B are the lengths of the two parallel sides. So here we can say that a half times A, which is 33, plus B, which is 42, times H, which is V, is equal to 120. Okay, so here we could multiply both sides by 2. Okay, so we have, first of all, we've got 33 plus 42, that's going to be 75. So you have 75, okay, V is equal to 240. I just multiplied both sides by 2, okay, and that gave you 75. So V is equal to 240 over 75, okay, and we have to just do that in a calculator, and hopefully it comes out as 3.2. 240 divided by 75 gives us 60 over 5, which is 3.2. So V equals 3.2. Okay, and that's the answer to part A. Okay, so that was 3.2 meters per second. And now for part B. In part B, they tell us to find the acceleration of cyclist P between t equals 0 and t equals 9. Okay, so if we consider this graph here, we found that V equals 3.2, so that's 3.2 over here. And we want to find the acceleration in this region over here. And this is a constant acceleration, as we know. And we know the acceleration is found by the gradient of a speed time graph. So we need to know the gradient of this graph. And the gradient of this graph is basically going to be the change in y, which is 3.2, over the change in x, which is 9. So the acceleration is, whoops, we need a pen, sorry. The acceleration is going to be equal to the change in y, which is going to be 3.2 over 9. And that will give us our answer, 3.2 divided by 9, which is 16 over 45, which is 0.35535 recurring, so 0.3555. Okay, so we can write that to 3SF So that's going to be 0.356 meters per second squared. So there's the answer to part B. Okay, so that completes A and B, and we're going to move on to C now. Right, so this is 3.2 meters per second. Okay, now, part B of the question, it tells us that cyclist P continues to cycle along the road in the same direction at the same constant speed. So he carries on after this, cycling along the road with the same speed. Okay, when t equals 6, which is over here somewhere, a second cyclist Q sets off from A and travels in the same direction as P along the same road. She accelerates for t seconds until her speed is 3.6 meters per second. So she's going to go up to 3.6 meters per second, starting from 6, okay, and accelerating for t seconds. Okay, so by the time it reaches, let's say, t plus 6 seconds, okay, she's accelerating for t seconds. So the time is t plus 6 seconds. She's going to be somewhere up there. Okay, good. She then travels at this constant speed, 3.6 meters per second. So she carries on going at the same constant speed. Okay, and then what happens? Cyclist Q catches up with P when t equals 54. So they basically then they reach the same place at 54 seconds. Okay, that's where they catch up. So let's say that's 54 seconds. Okay, sorry, I was just yawning there. So that's 54 seconds. Okay, so there's the answer to part C. We've drawn the graph, okay, up to 54 seconds for both cyclists. Okay, and we've got important information on there. Now we're going to go on to part D, where it says find the value of t. So how are we going to find the value of t? Okay, so we have cyclist P and cyclist Q. Okay, cyclist P is represented by this smaller graph and Q by the higher graph. Okay, now what I'm going to do is, you can see we have a shape here, which is a trapezium shape for both of them. Okay, what I'll do is this is P. I'm just going to copy the shape of the trapezium. Okay, so that's P. Okay. Let me just do this. Okay, so that's for P. Okay, so I've got the trapezium for P. I'm going to bring it down here and I'm going to make it a bit smaller. So that shows the journey of P. Okay, as for Q, I'll just choose a different color. I'm going to have a line, red. Okay, so this is for Q. I'm going to look at this trapezium, because we know that the area under a speed time graph will tell us about the distance that they traveled. And we know that these two objects, or these two cyclists, traveled the same distance. And basically, knowing that will help us to work out the value of t. Okay, so what have I done here? I've taken the thumb I'm supposed to take with me, no problem. I will just fix it when I get down there. Okay, so make this smaller. Okay, that's supposed to be a red line. Okay, no problem. All right, so now we have these two, and we now know that basically that one of them represents P, the other one represents Q. Okay, one of them represents P, the other one represents Q. So this one represents P here. This is the journey of P, and this is the journey of Q. Okay, and I know that they both have the same area. Okay, so the area, the distance they traveled is the same. How do we know that? Because they both passed each other, okay, at the same place. Okay, P set off from A, as we know from the first part of the question. Q sets it from A. So they set off from the same place at different times, but they end up in the same place as well. They finish at the same place. Okay, cyclist Q catches up with P when t equals 54. So that means they've traveled the same distance. So these two trapeziums represent the same distance. Okay, so I know that the area of a trapezium is given by the formula 1/2 times A plus B times H. Or you can say H over 2 times A plus B, where H is the distance between the parallel sides. Okay, the distance between them, which would be basically this. That's the distance between the parallel sides. They're not going to be the same here. And we know that it's like the perpendicular distance between them. And we also know that A and B are the length of the two pair of parallel sides. So these would be A's and B's for each of these two trapeziums. So for trapezium that represents P, okay, which is this one here, we see the distance between the parallel sides is 3.2. So here we have 3.2. And we see that the length of this top of it goes from 9 to 54. So 54 minus 9 is 45. So here you have a length of 45. And the length of the other parallel sides for the blue trapezium for P is from 0 to 54. So we can actually work out the exact distance they both traveled by this trapezium. And for Q, we have the distance between the parallel sides. In this time it's 3.2. Sorry, 3.6. Okay, 3.6 for Q. Right, so it's a larger one. And we have the distance from here is from 54 to 6, from 6 to 54. 54 minus 6 is 48. So that's 48 seconds. That's 48 is the length of this parallel side. And what we know is, and let me just move this here to make it clear, that I'm just putting it there so that we can see that this is the distance, this is t. Okay, this is the time that it takes to, accelerate. Right, that's what t is. And we need to find the value of t. That's what we need to find here, right? So the length from all the way from the beginning to the end is 48. From there to there is 48. And that distance is basically going to be, the distance from here to here is going to be 48 minus t. T goes from here to here. The distance we're looking for, which is from here to here, which is that distance, the other parallel side, that's going to be 48 minus t. 48 minus t. Okay, let me put that neater. 48 minus t. So I know that the area of area for P and is equal to the area of the trapezium for Q. Okay, because the distance traveled is the same. So we can say that we got 3.2 over 2, that's half of the height, times 45 plus 54 is equal to, for this one, you're going to have 3.6 over 2 times, and you're going to have 48 minus t plus 48. Okay, and that will give you your answer. This is going to be 1.6 times, that's going to be 99. Okay, is equal to, that's going to be that's 1.8 times 48 plus 48 is 96 minus t. So we're going to divide, we're going to do 1.6 times 99 over 1.8, and that's equal to 96 minus t. Take away t. So let's work out what this is. You have 1.6 times 99 divided by 1.8. That gives you 44 over 5, which is 8.8. So you have 8.8 is equal to, 1 second. .6 times 99 divided by 1.8. I knew there's something wrong there. Be careful. That's actually 88. Okay, that's 88. Be very careful with your calculator, not to make silly mistakes like that. So that's 88 equals 96 minus t. So that means t is equal to 96, take away 88, and that's going to be 8 seconds. Okay, 96 minus 88, 8 seconds. So there is the answer. That's the value of t. Okay, so that completes this question about speed time graphs. Okay, so other questions from this particular paper can be found in the playlist, which will appear on the top right of the screen at the end of this video. At the bottom here, you'll have a playlist dealing with travel graphs. You can subscribe to the channel by clicking on this link, and the video here will explain how to use my channel to find what you're looking for. Thank you for watching, and see you soon.